The last topic that we are going to discuss in columns is going to be the Rankine formula, which is an alternative formula for designing the columns. Now, in the previous session, you might be remembering what we have discussed. We discussed about the limitations of Euler's equations, where we saw that it is not suitable for short columns and various other limitations. Now, in order to overcome this particular limitation, these limitations, Rankine has introduced a new formula which is called as the Rankine formula, and it is represented like 1 by P is equal to 1 by Pc plus 1 by P. That's how it is being defined. Now the question is, what is Pc, what is P, and what is P? So P is actually the Rankine crippling load, the load that we are going to choose for the equation, that is called as the Rankine crippling load. Now what is Pc? Pc is the ultimate load for a strut. It can be strut or a column. We are not discussing about strut, we are discussing only about columns. And A is not here, given here. Anyway, P is the Eulerian load for the strut, not the strut columns. So this is Euler's equation that we have learned, pi square EI by LE square. So PE is the Euler load or the crippling load, PC is the crushing load, and P is the Rankine load. So how can you get the value of PC? PC is easy. PC is nothing but sigma ultimate into area. This is how we obtain the value of PC. P is obtained using the Euler's equation, and by substituting in this equation we can get the value of P. Now the question is how this formula works. It's also called as Rankine-Gordon formula. Now the question is how this particular formula works. It's very easy. See, the question is how this is applicable for all types of columns, like short columns, medium columns, and long columns. How this simple formula can be applied. And the answer is like this. See, for short columns, what is the condition? For the short columns, what happens? The PE value is very high, right? So when the value of P is very high, what happens to this ratio? This ratio becomes very small. Thus, we can eliminate this particular term, and what will happen? P will be equal to PC. Or in other words, we can say that design can be based upon the crushing load, not the Euler load. Now the question is, what about long columns? For long columns, what will happen? PE is going to be less, thereby this particular ratio is going to be high. So we can directly use P is equal to P, which gives P equal to P. And for intermediate columns, which we have not discussed anywhere in this lecture or in any other lecture, for intermediate columns, the actual design load will be somewhere in between this PC and P. So there we have to use these two equations or these two loads, PC and P, to find out the actual value of P. That's how this particular Rankine formula works. Okay, now we are going to derive a general formula for which can be used for all type of column, whether it is a short column or a medium column or an intermediate column or a long column. So we are going to derive that. It's pretty easy. So this is the equation after the cross multiplication. We have P is equal to PCP divided by P plus PC, and what we will do is we will take out P from the denominator. From here we will take out P and we will cancel out the numerator and denominator, and what is left with is PC divided by 1 plus PC plus by P. Okay, now we know that PC is nothing but sigma into A. We know that PE is equal to pi square EI by LE square. We also learned that I is equal to AK square. So all these things we are going to substitute in this equation. So which is nothing but PC is equal to sigma into A divided by 1 plus sigma into A divided by pi square EI by LE square, and again sigma into A divided by 1 plus sigma into A divided by pi square E into I can be rewritten as AK square divided by LE square, and when we solve this sigma by A. Sigma into A equal to 1 plus sigma into A divided by pi square E into A LE by K the whole square. So we can cancel out these two A, and what is left with is sigma into A divided by 1 plus sigma by pi square E into LE by K the whole square. Now if we look at this particular term, all the values which includes sigma, pi and E for that particular material is constant. We know that if you take the case of a steel, mild steel or something like that, the ultimate value is going to be some 330 or 450 or 550 something. That's a constant value. Pi, we have another constant. E, Young's modulus, material property, that is the another constant. So all these three terms gives us a constant value. Altogether we can substitute instead of these three as alpha. Alpha is called as the Rankine constant. So if we do that, we can rewrite the equation as sigma into A divided by 1 plus alpha into LE by K the whole square. Okay, so this is the equation where alpha is called as the Rankine constant. Okay, this value is like 1 by 400, 1 by 1600, 1 by 7500, like that. This kind of values can be obtained. These are values which are usually given in the question. Now there is another form of rewriting this equation like this. It can also be written as P by A equal to sigma divided by 1 plus alpha into LE by K the whole square. So please don't get confused with these two sigma values. They are not the same. This is actually the ultimate value and this is the one which is developed. That has to be distinguished clearly. Sigma u is the ultimate value, which is a material property, and this sigma is the one which is generated within the material. Alpha is the Rankine constant, Le is the equivalent length, which we have learned like 2L, L by 2, L by root 2 like that. K is the least radius of gyration. So this is the Rankine formula. This is the most commonly used formula for the case of columns. Now you kindly make a note of the value of K. How to obtain the value of K? We know that I is equal to AK square and K is equal to root of I minimum divided by A. This is the answer. So K is usually obtained by dividing I minimum divided by A and taking the root of that. So while solving a problem, we have to calculate the value of I minimum and we have to divide with the area and take the root to get the value of K. Usually K is not given in the question. Sometimes they will give only the geometry, the cross section. So it's our duty to find out the value of K. So this is how Rankine formula is derived and used. So different types of questions can be asked. So be very careful when you solve the problems. And this particular topic, Rankine formula, is one of the most important topic that comes under the columns. When you compare with Euler's equation and Rankine formula, this has a higher weightage when we compare to that of the Euler's equation, because this can be applied to any columns. That's the speciality of this problem. So kindly go through this formula and the different terms, how to solve the problems and all those things. See you with another topic in the next class. Thank you.